Hello, welcome back. Today we will be learning how to solve a system of equations by graphing. Yesterday we learned how to solve a system of equation by substitution, and we found the solution with an ordered pair. So as we can see, we put a graph in our system of equations solution today, so we can plot it out on the graph, unlike yesterday. And we'll be using different problems, and let's just jump right into it. So first, let's grab a paintbrush. I'm on a different painting website today because this is working better for what I want to do. So let's put in the problem that we will work on today. So y equals negative 1/4 x. X is the variable from what we learned yesterday, minus 4. So now we have the first equation, but since we are solving a system of equations, we will need to add our second. 3x plus y equals 9. So basically you see, oh, these are backwards. The equation signs are backwards, but you could flip these either way. You could have the 9 on this side, so it would be 9 equals negative 3x plus y. It's just flipped. You can flip it either way. You just can't flip, you can't, for example, put the 9 negative 3x plus y plus 9. You have to keep that on the same side, but you can flip it, yeah. So what we are going to do is we are going to find the slope for and the y-intercept for each of these equations. This is not the same as we did yesterday, where we tried to find the y-intercept. We did not try to find the y-intercept, rather the solution. Or we really didn't try to find the slope either, but today we're going to be looking at equations that both don't equal y like yesterday as well. So that's what's basically different. If you don't know what the y-axis is, this is the y-axis. On the graph, it goes up to 8, or rather 7. And then this would go up to 8. And then negative 8. This is what we call a 4-quadrant graph, where we do 1, this is 2, this is 3, this is 4. So we get 1, 2, 3, 4 quadrants of the graph. So let's hop right into this. This is the x-axis as well. So the y-intercept, which is always the other number in the problem, will fall on this line, and it will help us form our graph, or form our line on the graph, by giving us a starting point, and I will get into that later. So let's start off by finding the slope here for the first one. I'm going to write it down here in a different color, in red. So y equals negative 1/4 minus 4. Since the y-intercept is the second or the first number without a variable in the equation, we can see that it is negative 4. I forgot to put the x here. So it'd have to be negative 4 because negative 1/4 x has a variable, the variable x. So we're going to have to see negative 4. So basically, if we took away the negative 1/4 x, you get y equals negative 4. So the y-intercept must equal negative 4. So what we're going to do is we're going to write the y-int, or stands for intercept in this case, equals negative 4. Not just 4, not just minus 4, it is negative 4. That looks like a y, but that is a 4. then the slope would have to be negative 1/4 x, because the slope is always y over x. So yeah, it's y over x, so it would be negative 1 is the y over 4, which is the x. So the slope for this problem would be negative 1/4. So, real quick, let's place this on the graph. Let's place this in a red color as well. So, we're going to see negative 4, which is right here. So, our y-intercept is negative 4, so we're going to have to place it at the negative 4 on the graph. It covers it up, but negative 3, negative 3.5, and negative 4. So, what we get is the slope, which is negative 1 over. So, what we can do now is, let's fix this up here. Since it is negative 1 over 4, negative 1 is the x. So, first, we'd have to go down 1 and over 4. And this is actually 8 squares, but since it is a half, you have to go over 4. So if we do this backwards, because we can check, is that if we make this smaller, that is a very bad graph, or a very bad line. Look something like that. So what we're going to do is we're going to go back here to our 17, and we can check. If we go up 1 and do it in reverse and go back negative 4, it should land right on it. My graph is a little bit off, but it should be right on that line. You can also use Desmos, which is an online graph, and you should be able to get the right thing, I believe. But this is the way to do it on paper. So, next we are going to find, let's just erase this here. Okay. You can pause the video too back there if you are having trouble with anything during that part. I will have kept that up there. So let's do the second problem. Let's do negative 3x plus y equals 9. Well, let's see here. First, we're going to have to switch over, because it's going to have to equal y for it to be a complete graph. So y is on this side, but how do we get it to the other side? We're going to have to, we do not subtract y, because I'll put y on the side of the 9. We'll just go in an infinite loop unless we subtract another number. So we're going to add 3x. Since this is a negative, we're going to do the opposite. Just think that there is nothing behind it, or rather nothing in front of it, which there is not. Just think of it as minus 3x, even though there's nothing in front of it. Imagine there's a number here. So you would add 3x, since it is a negative, and you get y equals 9 plus 3x. So now we have y equals 9 plus 3x. What do we do? Well, we're going to find the y-intercept. This time it's positive 9 because it has no negative sign in front of it. So the y-intercept equals 9. And the slope equals 3 over 1. Let's get that in better here. 3. Oh my. I'm running out of room down here, but it's 3 over 1. So it'd be the y would equal 3 and the x would equal 1. So let's place this down. Let's grab, since we are out of room up here, I'm going to extend the graph just a tad. I did underestimate the size of the graph, but so that extends, that's 7, there, 9. So what we're gonna get here is, since this is 9, we can put our green dot at 9, which would actually be right here. And if we go down, because we don't have any room up here to do anything, we're going to have to do negative. So we're going to have to go down 3, 8, so this would be actually 7 because I ran out of room. So 6, 7, 8, 9. So 8, 7, 6. We're going down by 3, so 8, 7, 6. That is, oh yeah, right. And then you have to go over 1 because the x is 1, and since you're going backwards, so the graph is going to look something like this. So wherever these two plots intersect, this will be where your solution is. And since you can't get it just right here, on a regular graph you would get it. You would be able to find the plot, or where if you kept on making these dots down the graph and you kept on making these up, they would eventually fall at -4, -3, actually right here. This dot, because we did this and we went up and then we did this backwards, and it is right here. The graph will come down and it will meet right at this actual spot. So the solution to this problem would be -4, and you go down -3. This is the solution to this problem. Apologize about the graph today. Everything wasn't quite accurate, but this is how you find a system of equations, the solution to system of equations by graphing. Thank you and have a good day.